For number 12, we first have to make a brief table of values of t, x, and y. So I've gone ahead and I've done that. We can see that t is limited from -4 to +4. So I took values of t, so it went from -4, -2, 0, 2, 4, and I plugged those into the x equation and into the y equation. So when I plugged them in, we got this table over here. So for item B, they want us to plot the xy pairs in the table here that we've made and draw the parametric curve indicating the direction. So let's plot that in. And I'm going to scale it, I think I'm going to scale it by 4 here. So 4, 8, 12, 16, and 20. And I will do the same on the y-axis. So it's going to be 4, 8, 12, 16, and 20. Same thing here. Okay, so once we've scaled it in, we're ready to plot them. So we begin at t is equal to -4, and at t is equal to -4, x is 18, so we're going to be somewhere here, and y is -16. So we're going to be roughly here. When t is -2, x is 6, and y is -8, so we're here. When t is 0, x is 2, and y is 0, so we're going to be here. When t is 2, x is 6, and y is 8, so we can see that it's symmetric. And when t is 18, once more, when t is 4, x is going to be 18 once more, and y is going to be 16. So we're going to be somewhere up here, yeah. And we can see that this is the direction of our curve. It's kind of this parabola-shaped curve that opens up to the side. And the direction that we're going is in this direction here. And I'm just going to label it that this is when the point when t is equal to -4. This one over here. This is when t is equal to -2. When t is equal to 2, and this is when t is equal to 4. So we can see the direction that this curve travels. So we did item A, we did item B. Item B, which is up here. Now let's do item C, which is eliminate the parameter to obtain an equation in x and y. So we have that y is equal to 4t and x is equal to t squared plus 2. So the way that this curve goes, this is not a function of x because it fails the vertical line test, right? So this curve here is actually a function of y. We can model it as a function of y, which means that we're going to treat y as the input and x as the output. So since we want to treat y as the input, what we're going to do here is we're going to take this equation and we're going to express t in terms of y, because if we do so, then we can go to this t over here and plug in y, that expression of y which we get, thereby eliminating the parameter t. So we're going to have that y is equal to 4t, which therefore means that t is going to be equal to, we divide both sides by 4, y over 4. So once we have this, remember that our equation is x is equal to t squared plus 2. And since we have t in terms of y, we're now just going to plug it into the x equation. So, which means that x is equal to t squared and t is y over 4 squared plus 2. Which means that if we simplify this, x is equal to y squared over 16 plus 2. And this here is our Cartesian equation where we've eliminated the parameter, right? We can see that t is no longer there. But we're not quite done yet because the parameter, it is limited, right? It goes from -4 to 4. If we don't put a restriction, we're saying that this curve goes out to infinity, which is not true because the curve is limited. So since our input is y, what we have to do is say the values which y can take. Previously, the input was t, but now, because we're treating y as an input, we have to limit it. So we can see here on the table that y, it goes from -16 to +16. It takes on all the values in this range. So therefore, we're going to say that y goes from 16 to negative 16. So let me erase all of that so that we just get the important information here. So that's our curve when we eliminate the parameter and we express it in x and y. So we can put a check mark here. And now they want us to describe the curve. So what we can say is that this is a parabola that opens up to the right. And this parabola goes from the initial point. So we can maybe say a parabola opening to the right, going from the initial point, which was at the point 18, comma minus 16, to the final point, which is 18, comma positive 16. So that's the description of the curve, and that is it. We are finished with number 12.